Dear students, welcome to the third lecture on lasers. Okay, so in the last two classes we have discussed about the basics of lasers and derived the expression for energy density in terms of Einstein's coefficient. So today we will discuss about the basics requirement for the implementation of a laser. What we require to implement the laser physically. So there are a few things we should know before we go ahead for the physical implementation of laser. First thing is, let us see how we achieve the process of amplification. So this is the light amplification process. Okay, laser stands for LASER, that is light amplification by stimulated emission of radiations. It is an amplification process. Amplify the light. How we amplify? By increasing the number of photons. Okay, with the help of stimulated emission. So there is a acronym: light amplification by stimulated emission. We amplify the light, that is raise the number of photons with the help of stimulated emissions. Now here the same process is described. The picture on the screen will tell you the same thing. Suppose if I have a atom in the excited state, this is the excited state atom, and if I have a photon of right energy, if this photon interacts with this atom, it produces a stimulated emission, thereby giving two photons. So this one among them is the emitted photon and the other one is the incident photon. Now, though these are two photons that are obtained from the first stimulated emission, we can use them to stimulate other atoms in the excited state, Now these two photons, I will use them and I will stimulate the atoms in the excited state, thereby getting four photons, that is two from first atom and two photons from the second atom. Likewise, I get four photons from only one. Similarly, so I can use this four to stimulate other atoms in the excited state. Okay, this photon will interact with this, producing two. Similarly, this interact with this, that means all the four photons interacts with the four atoms, giving out eight photons. Okay, so basically I got one photon. From one I have eight photons. I should have only these excited atoms to get the photons. Got it? So if you look at these photons, all the photons are traveling in the same direction, all will have the same phase, all will have the same frequency or the energy. Therefore, we have increased the number of photons in it. Increasing the number of photons means we have increased the intensity of light. This is what we are doing. But the thing is, this photon number is not sufficient. Therefore, the photons should travel over longer distances. Okay, they should travel very long, and meanwhile they should all keep on stimulating the atoms to produce more and more photons. So this becomes a very disadvantage for that process. What we do is, instead of having this process, photons traveling over longer length, we will use a feedback system. Okay, where the photons travel between two stimulated points, between two mirrors, so that we can achieve this process of light amplification very easily. Let us see how it is done. Okay, this is the note what I told you. Light amplification process requires very large length of the photons to travel. Okay, requires very large length to gain the required uh, gain. Okay, they should travel a very long length. Okay, which is not possible. Therefore, a feedback system is used. That feedback is achieved using a laser cavity. Okay, let us see how the feedback system is present. This is the feedback system. Okay, it's an arrangement where we have two mirrors between our two mirrors. Between them there is a uh, medium where we get the light from. Okay, clear? So this arrangement we called as a feedback system. Okay, now initially I have only one photon and one atom. It produces the stimulated emissions. From first you get two photons. Likewise, two will give you four, four will give you eight. Okay, once they reach at this point, if the number is sufficient, a small part of the light will be tapped out. Why? Because it's 99% reflecting. Okay, if it is not sufficient, if it is not sufficient to act as a laser, what they do, what the feedback system will do is, again it will send back, it will reflect the light back in the reverse direction. You're getting the point? Once the light or photons are reflected back, okay, they in turn stimulate the other atoms in its path. That means if one of the photons, if one of the photons is reflected back, so this is one photon which is reflected back, okay, so in its path there is an arrangement for the photon so that it interacts with the excited state atom. So this is the excited state atom. So once it interacts with the excited state atoms, okay, it gives two more photons, okay. Now initially when it reaches there were some numbers, after that it is reflected back. Each reflected photon, I am showing only one, there are n number of such photons, all they are reflected back. When they are reflecting, they will have to interact with the atoms in their path, giving more photons. Likewise, when they travel in the reverse direction also, the same phenomenon takes place. So therefore, initially if you have small number of photons, when that photons travel from this end to this end, the number of photons goes on increasing. Again, if the photons, they move from this end to this end, again the number of photons are increasing. Likewise, first this is two direction and this is a four direction. So whenever there's a two as well as four direction, the number of photons goes on increasing. Suppose I'll show the next sheet, okay. So this is the case. What happens, I have the only one photon that I have shown here. Once the photon reaches this surface, if the number of photons is reaching the surface, this is 100% reflecting, okay. So all the photons will be reflected back again. Got it? So what happens when the photons start here, it is having only few number. When it reaches for the first case, it reaches some number. Again, if it is not sufficient, it is reflected back. Whenever it is reflected back, again the photons interact, thereby producing more and more photons. This process keeps on going. Only thing is that the atoms should be present in the excited state in its path. So it is the work of that feedback system, so that it always provides large number of such atoms in the excited state. Okay, clear? So therefore, the to and fro motion, the to as well as fro motion of the photons will increase the number of photons. So at this particular point, when the number of photons which reaches this end is sufficient, then a small part of that photon will be tapped out. That tapped out will be acting as a laser output. Okay, this is how the feedback works for a laser system. So with this in mind, we shall go for the requirements of a few terminologies associated with the laser system. Okay. So first one is pumping, second one is lasing, and the third one is the active medium. Okay, so what is this pumping? Let us go for the previous diagram to understand pumping. These are the excited state atoms. These are nothing but the excited state atoms. Okay, so atoms in the higher energy state, atoms in the higher energy state. These are nothing but the atoms in the higher energy state. You can look here. So these are the higher energy states. To get this higher energy state, we have to pump the atom. You are getting the point? They are not naturally occurable. We have the atoms in the lower energy state. We have to make sure that the atoms are pumped to the higher energy state with the help of the external energy. We supply the energy to the atom absorbs the energy and move to the higher energy state. You have learned the same thing, induced absorption. Okay, so this process of moving the atoms to the higher energy state, we call it as pumping of the atoms. Okay, so pumping process, okay, there are different forms of pumping, like optical pumping using the optical energy. Electrical pumping uses the electrical energy to pump the atoms. Next one is lasing. Lasing means obtaining the stimulated photons. Okay, not only obtaining stimulated photons, they should be occurring together. Okay, and they occur at a same time. The process of obtaining the stimulated emission after establishing the population inversion is known as the lasing, the process which leads to the emission of stimulated photons. Now if you go for the previous diagram, again I'll show the previous diagram. This is the previous diagram you have. Look at this. Look at this diagram. Okay. The photons, they are moving together. This is known as lasing, obtaining the stimulated emissions. Okay. Now, once the stimulated emissions are obtained, you get large number of photons. Now, this process is called as lasing. Okay. Now, the lasing is such that the atoms should be first pumped to the higher energy level. After pumping them to higher energy level, they should stay in the higher energy level for longer time. After pumping them to the higher energy level, we should get the stimulated emission. This process is called as lasing. So how it is defined? Let us check it. Okay, lasing is the process in which the emission of stimulated photons takes place after establishing population inversion. I will explain this population inversion in a later part. Okay, so this is the population inversion. Okay, so this population inversion I will discuss in the later part. Okay, so lasing is the process of obtaining the stimulated photons. Okay, go for third one, active medium. The active medium is a medium in which the pumping and lasing takes place. So here you have the atoms now which are giving you the light. These are the excited state atoms. Is it not? These are the excited state atoms. Okay. This gives you the photons. Clear? Now, without these atoms, you cannot have the photons. Clear? Without the excited atoms. So these are obtained from some medium. So that medium we call as an active medium. So active medium is a medium in which the pumping and lasing takes place. Pumping as well as the lasing takes place. That process is called as the that medium is called as the active medium. Active medium, which is giving you the photons. Okay, that is known as the active medium. Let us see how it is described here. Active medium, it's the system or the medium in which the pumping and lasing occurs. That medium is called as an active medium. In simple words, the medium from which we get the light are photons. It's known as an active medium. Okay, so with these things in mind, let us have the requirements of a laser system. We require three things for laser. First one is the excitation source, second one is the laser cavity, sorry, second one is the active medium, and third one is the laser cavity. Without these, okay, you cannot have laser. So all the lasers, they have one or the other form of excitation source, one or the other form of active medium, one or the other form of a laser cavity. Okay, without these we cannot achieve the laser itself. Okay, let us see for the first one. The diagram looks like here, like this. Okay, so this is the excitation source, first one. So you require an active medium, that is also there. Third one is the laser cavity. You can see the laser cavity. This is the laser cavity. Okay, let us go for the explanation for the first one, excitation source. Excitation source, as I told you, the pumping of atoms is the raising of atoms to the higher energy level. To get the laser output, I should have stimulated emissions. Stimulated emissions means I should have the atoms in the excited state. To have the atoms in the excited state, I should pump the atoms to the higher energy level. Okay, so this pumping of atoms to the higher energy level is achieved with the help of some external energy. That external energy we call it as an excitation source. Excitation source provides the necessary energy for pumping the atoms to higher energy level, for pumping the atoms from lower level to the higher energy level. That is called as pumping. This kind of pumping, okay, there are different kinds of pumping depending upon the laser. For example, in CO2 laser, we are having the electrical discharge as the excitation source. In a ruby laser, we are using optical energy, that is called as optical pumping. Okay, in a semiconductor laser, we have the PN junction as the active sorry we are having the in semiconductor we are having the forward bias, not the PN junction. It is the forward bias which is acting as the excitation source. Okay, depends upon the laser. Okay, next one is the active medium. Okay, so each laser has one or the other form of the active medium. Without the active medium, okay, it's not possible for uh, us to have the laser. So active medium is the medium in which the pumping and lasing takes place. Without pumping and lasing, you cannot have the laser. Okay, so lasing I have already defined. It is a process of obtaining stimulated emission. Clear? You cannot get the stimulated emissions if you don't have the active medium. Okay, so the active medium is a medium in which the pumping and lasing takes place. Pumping as well as lasing takes place. Clear? So it is the medium in which the pumping as well as the lasing takes place. In simple words, it's the medium in which the photons are obtained, in which the photons are obtained. There are different types of active medium depending upon the lasers. In helium neon laser, neon is the active medium. In carbon dioxide laser, CO2 is an active medium. In a semiconductor laser, PN junction is an active medium. Like depending upon the active medium. And the last one is the laser cavity. Okay, feedback system I have already discussed. It is used to raise the number of photons. Okay, in the laser system. Laser cavity consists of an active medium bound between the two mirrors. Such an arrangement we call it as a laser cavity. There is an active medium here. This active medium is bound between two highly polished mirror which are in parallel, highly parallel state. That system we call it as a laser cavity. Okay, so to have this amplification, we are using this. You're getting the point. The photons travel between the two mirrors. It will travel between the two mirrors. It will travel between the two mirrors from this end to this end, from this end to this. So this is to as well as fro, forward as well as in reverse direction. Whenever the photons travel to and fro motion, the number of photons goes on increasing as discussed earlier, and a small part of the light is obtained as a laser, which is from 99% reflecting mirror. Okay, clear? And there are few conditions. You cannot simply have the laser cavity like this. There is one condition. What is that condition? The condition is that the distance between the two mirrors, that is the length of the laser cavity, this is called as the length of the laser cavity, L. This should be of a particular value. Okay, why? Because I will tell you. To have the laser output, even though we have all the right conditions set up, but if you are not satisfying the condition for length, you will not get the output, laser output. What happens here is that in a laser cavity, I have two mirrors, two photons, which are in a laser cavity. There are two mirrors. Between them, the photons will be moving. For example, I have one photon here, which is moving from left to right. This is the laser cavity. Okay, I have the this is the photon, one photon which is moving in this direction. There's the other photon which is moving in the reverse direction. These two photons should be in phase. They should have the same phase. If they are not, if they are having the same phase, then they overlap in a constructive manner to give a standing wave like this. Okay, whenever you have such a standing wave, you get the laser. If you are not able to produce the standing wave like this, okay, then it is not possible to get the laser output. Let us see how it is. Okay, so so I have this diagram here again. So this is the one photon which is moving in a, this is the laser cavity. One photon is moving from left to right, other photon is moving from right to left. So this is one wave concerned with this photon, this is the other with this photon. Okay, the second photon. Now if they are in phase, they superimpose each other, they superimpose in a constructive manner to produce a very large amplitude. This is known as constructive interference. Whenever you have this constructive interference, then only you can get the laser output. Okay, to have this constructive interference, the condition is that the distance between the two mirrors, is L, should be always equal to m lambda by 2. If you are not satisfying this condition, then it is not possible to have the constructive interference. You are getting the point? Clear? You cannot have the standing wave, in other words. Okay, you cannot have the standing wave. Okay, there is other condition known as destructive interference. If the waves which are moving in opposite direction, if they are out of phase, okay, like this, if they are out of phase, then they cancel up each other, producing a null wave. So our condition is this: to achieve this condition of constructive interference, I have to set the distance between the two mirrors equal to L equal to m lambda by 2. Lambda is the wavelength, m is the integer. M is also called as the modes of the laser. Here, when we achieve this condition, we say that the laser cavity is under resonance. It is under resonance. The laser cavity is under resonance, and we say resonance is happening in the laser cavity, and it is vibrating with a certain resonating wavelength. That resonating wavelength is given by lambda, this is known as the resonating wavelength, lambda equal to 2L by m. So keep in mind, not only the laser you should have a laser cavity, the laser cavity should be such that the distance between the two mirrors should be equal to m lambda by 2, where m is an integer, also called as the modes of the modes of the laser. Okay, if you achieve this condition, then only you can get the laser. It is a resonating, we say that it is resonating at a wavelength. This is known as a resonating wavelength. Okay, so I shall stop here itself. In the next class we will discuss the rest. Thank you.